Okay. I hope this is working. All right, so this is for your separations class, your exam one, the part that was in class. So I'll try to keep this short, 6 to 8 minutes, not 68 minutes. So I want to show you something here. I'm trying to keep this short, so I'm trying to share the screen. By the way, I posted the solution on the grade already, and you did very well, but there was an issue mainly with part A. Why is this not working? Okay, here we go. Oop, that's not it. Here. Okay, so this was your exam, and it said that you had a mixture of two components that it was entering a partial evaporator, and it told you that, and I'll draw a diagram soon on my iPad. That part of it was turned into vapor. It's still a mixture of the two, and part of it remained liquid, still a mixture of the two. And then part A, it asks you to conduct a degree of freedom analysis to determine if you have enough information to determine the molar flow rate of the three streams entering and leaving the evaporator. So this means F, V, and L. So I'm just wanting you to see it, just in case you've forgotten about it. And now I'm going to draw it on the iPad. So share the screen again. iPad. No, it says I have to download a plugin. Wait, oh, it worked? What? I'm trying to do this quickly. So I'm just going to just. Why is this not working? Okay, all right, there we go. I think this is better now. I don't know what. Okay, here we go. All right, so for your exam, you have something like this, like in your classroom. You have a system, and this will be an open system, and you have entering a mixture of two components, and you will have some vapor exiting and some liquid exiting, and that F, V, and L will be moles per second. I believe that's how you've been doing it in your class, so moles per second. So then it asks you, how many equations do you have to find F, V, and L? So those are the unknowns, okay? Unknowns will be F, V, and L. And then how many equations do we have for those three? So it's asking you specifically for those three. So we know that we have this equation because there's no accumulation of mass inside of your open system. And then we also have this equation over here, and that's a Z, okay? Where I have that molar flow rate going in multiplied by, what was one? Oh, it doesn't tell you, but the molar fraction of component one is 50%. So then for component two will also be 50%. And then we have this equation where V is mole per second and Y would be how much, all right, so this doesn't have a unit, how much in percentage, or in this case, point something, of your stream contains that component number one, okay? And this will be in the part of vapor. You have something similar for your liquid, okay? And then you could also argue that you have this equation over here, okay? However, let me highlight these two. This one, F going in multiplied by Z2 equal to V Y2 plus L X2. However, this is equal to this, okay? You know that it will be Y2 would just be 1 minus Y1, and X2 will be 1 minus X1. So in your case, if you try to solve it, you know, if you try to solve your problem with those equations, I'm not talking about Raoult's law yet, then I'm just going to use another color, and you can skip to Raoult's law. You can skip the next few minutes. Why are you not letting me pick another color? There we go. If you're good with this, but I just want to show you quickly why this doesn't work. Like for your case, you have 0.5, right, times F equals to 0.576. These values were given, times V, plus 0.386 times L. This will be for component number one. And then I can write for component number two. Again, I have 0.5 F, and I have 1 minus 0.576, 424. And then I have 1 minus this value, so 0.614. And then if you try to solve with those two, also knowing that this one is true, then, you know, 0.5 F equal to 0.5 F, you get that 0.576 V plus 0.386 L equal to 0.424 V plus 0.614 L. And you can move things around, but you still do not have enough information because you don't have F either. Okay, so you do not have enough information with those. However, you know, if you include it there somewhere, I still gave you points. It's not like I gave you 0. Now, what about Raoult's law? For Raoult's law, we know that y of 1 will be of I, but let's write 1 over here. So the molar fraction in the vapor stream multiplied by the total pressure is equal to the partial vapor pressure of that component multiplied by x1. It's already been 6 minutes. And I can say the same for 2. So we say, okay, so what about these equations? Can they help me find V, L, and F? Well, no. First of all, V, F, and L are not there. That you might say, let's see, but X and Y, they are in those equations. So, you know, maybe I could use those equations. However, we know that the pressure, okay, and we could use log 10 or natural log, that pressure, not the total pressure, but the vapor pressure of that component, we can find it, but we need more information still. We also need the temperature. We don't have it, and we can do the same for 2, okay? Do the same for 2 with the Antoine parameters. We have the same temperature. So if you decided to include these equations, there are even more unknowns. But the thing is, and again, I didn't take off all the points. The thing is, the problem was not asking, you know, do we have enough information to calculate the temperature and this and this and this? It was asking, do we have enough information? It was trying to be simplified. Do we have enough information to calculate F, B, and L? And then you realize that you only have those 2 equations. If you introduce more equations, you have even more unknowns, and the unknowns are not part of the questions. So we're just going around in a circle. So hopefully that makes some sense. You still did great. There was an extra credit to make up for this. So let me know if you have any questions, and I hope that was helpful. And I'm going to go, so it's short, right? Good. Thank you for watching. If you're watching, if you're not watching, you're not, I don't have to say thank you. All right, I'm just going to go.